Welcome again to this session, session one. Actually, we are waiting for our speaker. So very soon she is going to join us. Then we will start. I would like to inform you all that the attendance link will be provided in between the expert talk in the Google chat box. So from there you can access. And if anyone feel any problem, please write me a message in WhatsApp. So I will provide the link on WhatsApp group also.
ఇది ఎప్పుడు మ్యూట్ ఉన్నాను ఓపెన్ ఉంది.
Good afternoon, ma'am.
Good afternoon. Am I audible to you?
Yes, ma'am, perfectly.
Okay, fine.
Okay, ma'am. So, shall we start, ma'am?
Yes, yes.
Okay. So, I'm going to read your biography, and after then we can start. So, now I welcome today's speaker, uh, Professor Premlata Jena, ma'am. Professor Premlata, ma'am, received the BTech degree in Electrical Engineering from Utkal University, Odisha, India in 2001, and the MTech and PhD degree in Power System Engineering from the Department of Electrical Engineering, Indian Institute of Technology, Kharagpur, in 2006 and 2011, respectively. She had worked as an assistant professor with the Department of Electrical Engineering, IIT Roorkee, since 2012. She has been currently working as an associate professor with the Department of Electrical Engineering, Indian Institute of Technology, Roorkee. Her research interests include power system protection, microgrid protection, and issues due to the integration of renewable with the existing power grid. She was a recipient of the Women Excellence Award 2017 from DST New Delhi, the Young Engineers Award Indian National Academy of Engineering, and the POSCO Power System Award Power Grid Corporation of India Limited, India in 2013. She has executed projects from the various organizations like DST, SERB, CPRI, THDC Limited, etc. She has published research papers more than 60 journals and a conference paper in repeated journals and conferences. So with this, I welcome and invite for the expert talk from Professor Premlata Jena, ma'am. Ma'am, please.
Okay, so thank you, Rajkumar Patel. So a very good morning. I think it's afternoon. A very good afternoon to all of you, all the participants and the coordinator. Thank you for inviting me for this talk. And so let me share my presentation to all of you, and then we'll start. Now this visible to all of you. Is it visible?
Yes, ma'am.
Okay.
It's visible.
So kindly just I request all of you kindly mute your mic. I request all the participants please mute your mic.
Okay, it is requested to all the participants, please mute your mic so that, yes, ma'am, everyone is muted now.
Thank you. Okay, so yes, some noise is coming. Some background noise is coming. Okay, so a very good afternoon to all of you again, and thank you for saying few lines about me, and I'm really thankful to you people. So today, the topic on which I'll talk is vision towards smart grid or a smart grid a vision. So basically, in this particular lecture, so what I'll do, I'll just talk to you like what is smart grid and then why it is important in today's state and what are the merits and demerits and so many like motivational things, encouragement. So everything we will talk about regarding this topic. Okay. So if you could see my first the slide that just a minute. So if you see that in today's state, so we are moving towards the smart grid era, or you can say environment. So now what is the need of it? So that slowly I'll talk to you. And what is smart grid and what is the essentiality and what are the features of the smart grid? So one by one, I'll talk to you. Now you could see this first PPT, the left side and right side. You can see these two pictures that suddenly it will just will be confused, some kind of buzzing pictures. But fortunately, now in today's date, in 2021, so these pictures are not anymore very confusing or buzzing pictures. Rather, it's a real requirement for all of us. Like this side, if you could see, we have like coal-based generation. This is the smart grid, and this is just connecting so many aspects, so many utilities, so many loads, customers, right? And the goal, the center point is the smart grid. And you could see here, like we have thermal power plants, we have hydraulic power generation, we have solar, we have wind, we have electric vehicles, we have residential loads, and so many points. Okay. Now, if you go to this side, that this is actually the another picture, which is the starting of this my lecture, that you could see how this what is the in between. Like you have the power layers. Okay, so along with this power layer we have something else, like you have wireless smart meter sensors, like we have cloud-based servers, we have smart grid operators, we have energy supplier. So what is this landscape, like smart grid cloud integration landscape? What I'm trying to say that from this small picture, it's basically the starting point of this lecture, that the smart grid is very upcoming field with a very promising aspect and promising signal. Okay, it's a very promising field, and slowly we will learn. The first point will be I'll focus that why smart grid and what is smart grid, and what are the smart grid characteristics. It's a discussion, it's a behavior, it's everything features one by one we'll discuss. Now, so coming to this next one, this picture, if you see that in today's date, up to 31st March 2020, our power, generation from all the sources is around 370.10 gigawatt. So out of this 370.10 gigawatt, so maximum we are getting around 55.4%, almost 205.13 gigawatt from the coal-based generation. So this brown area, if you could see, that is the coal-based generation, and like green area is around 23.5%, and that comes from the renewables, except the large hydro power plants. Then we have large hydro around 12% and gas. Now this is a very common thing. We all of you know it, but still, why this picture is keeping in front of you, or we are interested for this, because as soon as possible we have to reduce the coal-based demand or coal-based generating stations, because the coal-based generations are completely dependent on coal, and very soon we are going to adjust this coal belt. And again, the second thought process is the carbon dioxide emission footprint. That is also one of the worrying factor for all of us. And the pollution and the other gases, poisonous gases, are also the worrying factor for all of us. So the environment issues, like eco-friendly issues, are in the front end. So therefore, we have to definitely increase, because see, at the same time we are going to cut down the solar-based generation. So definitely we have to increase the consumption from the renewable head. So this green belt should increase, and the brown area should reduce and the green area should increase and the brown area should decrease. So that means what I'm trying to say, because we cannot stop the demand, because India is the second largest population in the world, and then if the population is there and our country is moving towards a like tag of developed nation, so in that sense what so sorry sorry so in that sense we are basically trying to be developed. So of course we cannot stop the consumption, we have to consume the in fact I was going through many records, the consumption is moving like in exponential manner, the demand is increasing in exponential manner, so we have to fulfill the demand. So in that sense if you are cutting down the coal, so of course we have to take some alternate. What is the alternate way out? So that is the renewable source. So renewable sources are very unpredictable nature, very uncertain in nature, very kind of, intermittent in nature. So very unpredictable, intermittent, and uncertain. So to handle those uncertain energy systems, so definitely we need some sort of assurance from the network or operators or controllers that, okay, so our technology is ready to accommodate such uncertain or intermittent energy sources. So these are some of the thought process from this particular picture. It is not that nobody knows what is the installed capacity or how much comes from the coal-based generation, how much from the renewables. Of course, we have to know those figures, but at the same time, we should be very much careful that what is our aim. So our aim is to harness maximum and maximum power from the renewable sources. So in that sense, coming to the renewable source front, what are the contributions in India? First, you see that by 2020, we have a good figure. That is, we cannot say an excellent figure we cannot say. Of course, we can say good figure, that is 87.02 gigawatt. And moreover, by 2022, we are targeting around 175 gigawatt. And again, further, if I'll just proceed, by 2030, we are targeting around 300 gigawatt of renewable energy integration to the existing network. So in that sense, what I'm trying to say that this wind is almost around 36.368, around 45% of our total renewable generation. And similarly, the solar is around 36.7%. And biomass, small hydro is also one of the promising field, but still I'm just so I'll just tell you what are the kind of ways out missions we have conducted towards this small hydro power plants. So that small hydropower plant is around 5.7%, right? So this picture we have to increase. And of course, I understand that wind and solar are plenty available throughout the, like we have great potential regarding these two sources. But however, we'll go for small hydropower plants. Of course, it is kind of region oriented, geographical region oriented. So, but we have to explore more for the small hydropower plants as well. And mostly this if we could see, any one of you have some ideas, like in India government has a small hydropower plant mission. So there actually the government is encouraging the areas like northern grid, northeastern grid, where there is a good chance of water resources, and we can have small hydropower plants, and we can increase the generation from that side. So that is a point that India is progressing very nicely as far as the like this renewables are concerned. And mostly here one point I just want to just share with all of you, that India has a great potential as far as the wind and solar is concerned, and also not bad in case of small hydropower plants. But mostly our target is going towards wind and solar. So, like, next, for this smart grid, what are the ways out? What are the major concerns? One by one, I'll discuss with all of you. So this is one of the thought process I just want to share, that from the 2-3 slides I said that in a point-wise manner, I said very quickly we have to overwrite the coal-based generation with help of the renewable generation like wind or maybe rooftop solars or some solar energy parks or wind parks. And not only that, and those renewable sources are very intermittent in nature, changing in nature. So we have to basically accommodate those renewable sources to the existing network. So for that, smart grid technology, we are hoping, is one of the best technology which can help to handle those resources. And the second thought process, what I just want to share with all of you, is the major disturbances and which are happening in our network. Because let me tell you, this electric network is the largest man-made network, the largest word I used. It is actually man-made, but you cannot bring some machine or you cannot construct within a night, over a night, some towers or transmission line or distribution lines, transformers. We have to put lot of effort to stand one infrastructure. So in that context, the electric network is one of the largest man-made infrastructure as far as the transportation is concerned, water supply, communication infrastructure, energy infrastructure. So this electrical energy infrastructure is one of the largest man-made infrastructure. And not only that, at the present situation, we have 5 national grids. We have northern grid, and we have, this is our northern grid, and this is our northeastern grid. We have southern grid, we have western grid. So there are 5 eastern grid. So we have 5 national grids which are actually connected with each other. Okay. Now, these are connected with each other, that is true, that is fine. But if any disturbance occurs at any point, right? So what will happen? Basically, the thing is we can lose some kind of situation may arise where that one disturbance may cause so many losses, right? So one sample thing I just want to share with all of you, that this is the case. Once there was a blackout in the year, here I have written, in the year July 31st, 2012. And what happened, one 400 kV line was connecting from Bina to Gwalior. Okay, so this line was connecting Bina to Gwalior, and that line was overloaded. And what happened due to this overloading capacity, that one of the distance relay, zone 3 relay, has tripped, and the breaker was opened, and line was opened. So therefore, what happened? Rest nearby lines, they have tried to carry the power from western region to the northern region, to the western region. So the power flow was moving like this. But what happened? Slowly, the other lines get loaded, and those lines also started to trip. And slowly what happens, this kind of failure mode is known as cascade failure mode of the lines. And as a result, the load was decreased, and the northern grid was under blackout conditions, and the loads are also going to, because when the power generation and the load mismatch take place, the voltage frequency mismatch takes place, And so we have to either shut down the generator, we have to shut down the loads. So we have to do some alternating. Okay. So in that sense, what happened? In that year, 2012, July 30, 31st, our northern grid and northeastern grid together, the largest two grids was under two grids were under blackout condition. You can see this one, even including Odisha, Jharkhand, Bihar. So see why I'm saying this. This is small disturbance that this disturbance had happened due to the load encroachment problem. So this load encroachment problem means you have increase in load in the heavier loading of the line, higher loading of the line. If it is happening for a small disturbance and it is taking a long way life, how can I tell you? Like during this period, so rest of these areas you see for 2 days they were under blackout. So many critical loads they suffered. Like many like airports, some industries, some hospitals, some school, colleges, so many institutions, so many agricultural loads, industry belt, so IT sectors. So they suffered a lot. So with that process, we have taken like a long, loss, kind of regarding the money as well as the life and every sort of like, problems we faced. So the question comes that after that, the government of India has tried to just investigate what is the problem, why it had happened, and how we can check it. Such kind of disturbances we do not need, and we have to make our network smart enough so that this kind of disturbances should not persist, even though it will come, so we can handle easily without affecting our network operation. So that sense, I can tell you one event, like during this process, the Delhi metro and Delhi airport were disconnected, and they both the networks they operated in an islanded mode. And finally, what happened when they operated in an islanded mode? So we could solve like Delhi metros, Delhi airport, and many other critical nodes. Okay, so these are some of the like thought process I'm sharing with all of you, and so how we can solve this kind of disturbances using smart grid is one of the major concepts. Now, the third point, here I'll discuss two major points with all of you that you can understand that why this smart grid is very essential. The first point here, the conventional grid we have, but still we are interested for smart grid. That is what is the discussion I'm going to take over. So the point is the conventional, you can write even or you can just keep in track. So the earlier, the conventional grid, the first point was like the operational behavior was unidirectional. Unidirectional means the power was flowing or its power was pushed from the one generating station to the load centers. So this power flow was unidirectional, and the utility has to supply the power to the loads, and the loads cannot supply power to the utilities. The load has to accept. But now the scenario has been changed. The load can also share or supply power to the other utility side or maybe some nearby loads. So this kind of bidirectional facility we need. And second, in the conventional grid system, we don't have any facility of storage. So suppose we have some surplus power or not even surplus power, suppose we need some extra power like peak demand. So during the daytime, the morning hour or evening hour, we need some kind of peak demand. So that time if we have some storage, so definitely we can take the power help from the storage facility. But of course, if you could remember, maybe before 5 years, 10 years, the storage capacity, the evolvement or like of evolution was not there because we don't bother about it. But now the situation is like that. We have lot many electronic gadgets. We have lot many electronic gadgets, flexible devices, smart devices, so which need the supply quickly without any delay. So in that sense, the storage can be a good option if you can add some smart grid technology, the existing network. The third point that earlier in the national grid or smart or conventional grid, there was no communication facility. So what is a communication facility? Like in a rural city, if you could see some power outage is there due to some transformer damage or some line outage or some line down, overhead line down. So in that case, it will take minimum 1 to 2 weeks, a month or years to repair and again to come back to the original state. So this kind of scenarios we do not want to repeat again. So we want some good facility. So through this smart grid era or smart grid technology, so where the even though we have certain disturbances, we have some problems, the customers can easily communicate to the utilities, and so that the utility can take over to charge and repair, and the queue person can reach the center, the point damaged area quickly, and they can just repair as quick as possible so that the power supply should be intact or can be maintained easily and to supply quality power to the customers. So in that front, this communication facility will help a lot. Okay, and the fourth one is like in the conventional grid, flexibility. This picture, this slide, you can see need for flexibility. This flexibility is diminishing form. Why? Because there are some straightforward conventional static rules and regulations. We have to follow that, and the customers have to follow that, the utilities have to follow that, and so every medium operator, service provider, they have to follow that. But in fact, I'll tell you very happily that in smart grid technology, smart grid era as a vision or it's a product, and you can conclude at the end of my presentation that with the smart grid technology, we can make our conventional grid more flexible than what it was previously. And not only that, one picture, one example I will put in front of you, with all of you, that in US, there is a good practice that they have already demonstrated this capacity and this philosophy that if a customer, suppose she wants to like purchase low priced power supply, suppose in the morning 6 to 8, so the price is down. So he can just engage the ports over there, and to that it will decide. And next, suppose 8 to 10, suppose the flexibility is good, like the price of the energy is low. So in that case also they can plug in to that particular agency. So similarly from next onwards. So that is known as scheduling of their load utilization depending on the price of the particular utility. And of course the quality of the power supply. So this kind of flexibility we need in our network as well. And so that the utility, like suppose if you go some, I have seen in many cases a smart home or smart room, smart office room, means like if you like smart kitchen and smart, I mean kind of bedroom, smart office room. So what you do, how much I have just recharged my card, so up to that period my AC will run or my light will be glowing. After that my heater will be on, and after that it will be off automatically. So this kind of thing is coming very quickly, and this in this process we'll be very conscious for utilizing the power properly or energy properly. So if the utilization energy we are utilizing very consciously and a very efficient manner economically, so you can understand what I'm trying to say. So obviously we will be living in a very economic, a very efficient energy environment. Okay. And in fact, how much energy we are investing day-to-day life, you cannot imagine. So even today in India, our population is very high, and many, like 20, 30, maybe more than that. Picture exactly I could not put in front of you, but you can change it and from the net, and you can see that. So when this picture, like it is even though we are in the smart grid era, so this picture is increasing. I mean, this figure is increasing. The percentage of people, they are not able to utilize the energy properly for their day-to-day life. So why is it so? Because maximum the energy we are wasting. So the losses, in the form of losses. So and even then not efficiently we're using the energy. So therefore, this is one of the important thought process. So in that sense, we are developing smart inverters based AC, smart inverter based refrigerators. I'm just talking household things so that we can easily understand the concept. Uh, Smart cars, smartphones. So and smart buildings, smart machines. So slowly we are making every equipment as smarter. So what is the meaning of that? The meaning is this only: we are trying to utilize the energy as much as less possible, but however our outcome will remain constant or maybe more than that even. Okay, so without any loss or very casual use of the energy. Okay, somebody has forgotten at their home that I forgot to switch off my light and switch off my bulbs, switch off my TV, switch off my this that. So that is not a good option. But the point is, if I can switch off my bulbs, lights, TV, refrigerator from my office, even though I'm at a daily or some other places, so it is quite good. So those kind of flexibility we need in terms of smart grid technology. So therefore, this is one, thought process, different thought process motivations I'm just giving, that why we should aim towards a smart grid era, and what is the problem with the existing platform or existing conventional grid. So this need for flexibility, I hope you can understand with 2-3 examples I just gave to all of you. Like, we are also trying to have a very good platform which is coming nowadays. We have like uh, all of you know that 5 customers, like 4 customers built. Like, we have residential customers, we have industrial customers, we have agricultural customers, and also commercial. But now the 5th dimension is added, that is the transportation customers. So there, the electric vehicle is going to be one of the best role model. It will just utilize the energy efficiently, and it will just help us in reducing the pollution in the environment. And so these are some of the thought process we are just building up, and slowly I hope that we will be able to build such our journey, and our research capability will be converted to the actual reality very soon. So this is the thing. So last point I just want to add, that already, let me just repeat it again. Like, in that, what are the shortcomings associated with the existing breed? The first one is, it is the power flow is indirectional. Then we don't have any storage facility. Then third one, we don't have any communication facility, and we don't have any controllability, like all this, like in smart grid, all the equipment, they talk to each other. Like, one device can talk to another device, the utility can talk to the customers can talk to the utilities, one customer also can share with another customers, like that. So this kind of talking and the communication facility is known as interoperability. Okay, so interoperability. So this kind of things we have to promote. We have to make it to a larger extent, a larger scale. Okay, so and we have to bring to the reality. It is not that it should be in the pen and paper, bookish knowledge and pen and paper form, but we should bring this thought process to the reality. Okay, so, and the last one, fourth, like, we have losses. the huge losses, like while we are transmitting power from the one generating station to the load centers. So the huge transmission line, the pathway, on the way we have to, the power has to travel. So I square R loss will be there. That is around 10%, 10 to 15%. So those losses we have to reduce. So we can have like the power supply near to the customer end. So in that sense, we can save those losses. So these are some very honest things I just kept in front of you. I think all of you will be agreed with me. You will not be disagreed with these points that yes, it is the reality. So for that reason, we need some flexibility, like increasing the grid size and complexity. And it is also seen that if we increase the AC grid size, then suppose keep on increasing the size, in the sense I'm talking power handling capacity, if we keep on increasing, then what will happen? It is also seen the what much, I mean, the effort we put, the desirable output we may not get. Effort is not equal to our output. Our benefit is less. If effort is 100%, benefit is around 30%. So for that reason, it is better to move towards a smart grid era or macro grid era, so where all flexibility can be embedded, and as a result, we can have some kind of like this kind of problems what I have just mentioned, we can handle easily. Okay, so this increasing grid size complexity we can handle definitely through smart grid. Demand growth, already I have discussed with all of you. Increasing energy trend, like the energy trend what we're expecting than the previous last decade, it is something different. So as I said, to remind to all of you that this power demand is having an exponential curve. Okay, and changing load flows, the power now. Let me tell you, this power flow direction is changing from any direction, because we are penetrating the renewables from at any center, at any state, at any region, at any district, or some village, or some town, urban cities, wherever. So this penetration of renewables are extremely very, it is very unpredictable. We can penetrate the renewable sources at any point. And then we have bulk power transmission. We have to transmit more power, which is actually not a good sign. We have to rather, we can keep our generating station near to our customer, and bottlenecks, overloading of the lines. So if we can handle these issues, so definitely we may have like an efficient, reliable, and very secure. And one more term I have missed here, that is the we could have a very sustainable power network. So the sustainability what comes from the integration of renewable sources. So from this small discussion, you can also read more, and you can like investigate more about it. What I have just informed to you, these are my small knowledge domain. You can also access more points, that what are the drawbacks of the existing, I mean, in fact, the static nature of the conventional grid cannot allow the integration of renewable sources, or integration of like our aim, desire, and our requirements very quickly. So we have to take some steps ahead. So that is what is the smart grid vision. Okay, so from the so many information, like many kind of forum, many kind of people, they are just coming together and they are just deriving the definition of smart grid. So you may ask me that after a long time, you are saying the definition. See, if I could have told, I mean, from the beginning, the definition, that may not be perfect, that may not be correct. So unless until we see, actually when this movie will be started, so of course there will be some background. So we have some trailer, so some information regarding the movie, and then things will be understandable and interesting. So therefore, this, if you're going to see this smart grid definition, some sort of like some light throw is required regarding that path. So now we can understand what is smart grid. So definition is nothing. The definition comes from lot many analysis and lot many realization, implementation. So then only this smart grid definition has come. So the first definition is by Energy Future Coalition that the term smart grid refers to an electricity transmission distribution system that incorporates the elements information technology, communication technology. That's the single term we call it as ICT to provide a better grid performance to support a wide array of additional digital aids and services to the customers. So let me simplify. Many authorities, like we have Global Smart Grid Federation and US Energy Department, Indian context. So there are so many organizations, they have given different definitions. So the first foremost, I just want to simplify it, those definitions. I just want to merge together and finalize one definition and one goal. What is that? So on the left side, we have the conventional grid. Conventional grid, I hope you all of you understand. The right side, we have renewable sources, we have storage. That is along with that, we have a very good dedicated information communication technology, smart sensors, and a dynamic and adaptive self-healed controller. When these two things you merge, they get married. So there is a birth of one child, that is a smart grid. So that means we are just combining together. We are not forgetting our conventional grid. We are making the existing grid as smart. And what are the things? What are the requirements? What are the technologies which will enable it to be smart? That we have to think of. We have to think upon it. So that is what is I'm trying to say, that if you just combine with this existing grid with the information technology, communication, and those technologies are very much dedicated. Like some for some purpose we are using the computer and communication technology, we will borrow from there and utilize for the electric network. That will not work. So we have to very much dedicated, kind of very fast, accurate, and advanced information and communication technology, which is going to be embedded or attached along with the smart sensors and controllers to the existing power network. Okay, so that will give me a new generation, new era, a new grid, which we are calling as smart grid, and that will operate automatically in an automatic manner, in a resilient manner, and in a self-healing manner. So this grid should be self-healing in nature, resilient in nature, and self-corrected. It can just correct itself. It can detect the disturbance itself. It can correct by itself, and it can run by itself. So those innovation is not so easy, and rather at the same time it is not so difficult also, which is not impossible. It is quite possible. So we have all sort of tools, we have all sort of technologies, but we have to utilize it. So for that, what we need, our vision should be strong, our goal should be strong, our understanding should be strong. Okay, so then of course we can stand, we can do anything we like. So that is why the topic I kept that smart grid as a vision. So it is not a product, rather it's a vision. So somebody think that no, smart grid is like is a regulator, like a stabilizer. So we'll go to the market and some solution is existing, and we'll purchase and we'll connect at a doorstep, and somebody will supply at a doorstep, and that will solve my problem. That is not possible. It's an evolving process. Things are going. We have to keep on changing our vision, keep on analyzing, keep on doing research, keep on implementing in this era, so that finally we can get some efficient and economic and sustainable environment. So this is how the things go. As I said, already I have discussed what are the characteristics of the smart grid. It should be reliable, self-filling, self-monitoring, more secure, cleaner, greener. It is obvious because, as I said, we have actually in India, I mean, maximum IITs and IITs, they are involved in this project. Maybe some colleges also, government colleges, private colleges, so universities, they are involved in the various projects. We have some mission innovation strategy where we are aiming some 100% renewable integration to the existing grid. So if you're trying to have 100% renewable integration, so do you think that it is a very small job? No, it's a very big task for all of us. So this renewable sources which are going to be integrated. So in that process, the smart grid rhythm can be cleaner and greener in operational wise, loop wise, and from every aspect. Okay, support widespread distributed generation, help customers better control energy in their homes and businesses. Already I discussed, I have thrown some light in that regard, how in US the people are trying to utilize their energy, and even Canada. So they are utilizing the energy in an efficient manner, so in a smart manner. So that is very essential for all of us also. Okay, so lower pricing. So those so many aspects are there. So therefore, this is now none of these definitions convey clear, complete understanding of smart grid. Rather, smart grid is not a product; it's a service. So it's a vision that can be expressed from various perspectives. So that therefore, it's a service. Like I mean, whether it's a product, no, we have to keep some track of some vision, so which will help us value. Okay, so till this point, if you have some questions, I can also take some questions, and I'll just talk about the next part of my talk. So if anybody has some any queries, all of you are most welcome to just share with me. So if you have some doubts till this point, and I'll be very happy to do so. Otherwise, I'll just continue with my next part of this project presentation. Any questions from your side, participants?
Any question from the participant? Please ask.
If not, then we end. We can take at the end. We can take. Okay.
Okay, ma'am.
I'll continue. Shall I continue?
Yes, ma'am. Yes, ma'am. No any question from the participant, ma'am.
Fine, fine. So I'm continuing. So next phase, I'll just continue with what is microgrid, types of microgrid. So now you may be astonished that why I just came quickly from smart grid definition and all to microgrid definition, right? So here, very first point I just tell to all of you. Let me tell you, this microgrid is the building block of smart grid. Okay, so you may tell me why this microgrid is required, how it is linked to the smart grid. That I just want to inform you. Then we can continue further. So this micro, you can understand this micro is 10 to the power minus 6. So this grid, somebody will ask you what is the capacity of a conventional grid. So that is in the range of gigawatt. Okay, so when we'll multiply this 10 to the minus 6 with 10 to the 9, so it will be in the range of some kilowatt. Okay, so in that sense, this microgrid helps in scaling down the power usage to low level. So according to IEEE standard, this microgrid can handle the power up to around in the range of 50 megawatt to 100 megawatt, and the voltage level of like maybe 33 kV, 11 kV, or 440 volt level, the low voltage level. Okay, so mostly let me make it clear. So this microgrid is the small building block of the smart grid. Just like where we have some structure of building. So in the building, the bricks are the building blocks. So we are connecting together. So similarly, the microgrid is the smallest cornerstone of the smart grid. So for example, we have some areas like in district level. So we have made some sort of like different microgrids, microgrid 1, 2, 3, 4, 5, like this. So multiple microgrids which are connected together, it is called as networked microgrid. And those networked microgrids are further connected in the state level, and from the state level we can go to the national level. So slowly we can build our smart grid structure from a microgrid level. So I think you understood what is this microgrid. It is the smallest unit of the smart grid. Now the next question comes, like whether all the smart grid we can call it as microgrid, or all the microgrids can you call it smart grid? Yes. So every smart grid is a microgrid, but all the microgrid may not be a smart grid. So I'll tell you why it is. Because let me tell you, as I said from the definition side of the smart grid, that in this microgrid, let us say we have some energy layer, power layer, or power domain. Power domain means, just to see this picture, we have this blue side. This side is the coal-based generation, and some, or maybe you have water-based generation, hydro-based generation, and those power they're transferring through transmission line. It is going to the distribution sector and the customers. So this area is known as a microgrid. This square one, the rectangular portion, red one. This we have residential loads, we have commercial loads, we have different active loads, and so this total area, it can either be connected to the main grid, or it can be on. And also of course we have storage, so or it can be disconnected from the main grid, and also it can operate in an islanded mode without the help of the main grid. So this area where we have renewable sources, we have loads, we have storage facility. So those area we call it as microgrid, and it has a handling capacity of power, maybe some megawatt or some kilowatt range. And now, so this particular integrated system, which is consisting of connected loads, distributed energy resources, which as an integrated system can operate in parallel with the grid or in an islanded mode. Now, so according to this IEEE standards, so we have a, as I said, if my question whether every smart grid is a microgrid or microgrid is smart microgrid or not. We have a power layer. The power layer is based on the renewables or storage of the grid. Now, above it, we have the communication layer. Above it, again, we have the information technology layer. Above it, we have the sensors and the adaptive controllers. So together, if you are adding all these layers and you are making it interoperability and enabled network, smart enabled networks, of course we can call it as smart microgrid. Otherwise, by simply just integrating renewable storage or loads to the existing grid doesn't mean that our microgrid is not enough. Okay, so this is how the definition of microgrid is, and these are the major components of this microgrid. We have energy management system. The first one is we should have a energy supply system, and those energy supply system like renewable sources and small combustion turbines. And we should have some storage like lithium ion batteries, thermal storage, and then we have some demand response and efficiency measures. We should have energy management system, and of course, as I said, the utility grid interconnection. So the utility should be connected to the system. So these are some of the components of the microgrid. Now coming to another aspect, another good information I just want to share with all of you, that we have one mini grid concept. So this mini grid concept is nothing. This is actually just after your microgrid. This mini grid operates at less than 11 kV voltage level, and it involves small scale electricity generation around 10 kilowatt to 110 megawatt range. And just I have shown here one picture for your understanding that here is initially we have, let us say, some solar park. Before that, I just want to share with you, I have seen some experienced points in South Africa. There are some remote villages, areas where there is a very less chance of like reaching to the main grid supply. And there, this mini grid concept is very good. And in fact, many other US-based companies, they are just making their own like demonstrative projects over there. So they are just keeping some solar park near 2, 3 villages, 4 villages, or maybe one village area, and they're keeping some solar rooftops or some solar park, and from there supplying the power to those residences and some agricultural loads as well. Because in rural facility, mostly we have agricultural facilities and some residential areas. So the solar, for that reason, I have just kept this picture, and that is a reality, real example of the mini grid. And so this is solar photovoltaic generation system. And here is, the output of the solar is DC, so it will convert DC to AC. Okay, and then this DC will be stored in some storage device, and we have one transformer. If your generation on the inverter side is low, so it will convert to higher voltage, and that voltage level should match to our distribution voltage level, maybe some 11 kV or some more less than maybe 4.16 kV, some other voltage level. And from there, it will go to some agricultural processing facility and some residences. So this is how the mini grid layout goes. So now we here you cannot see any main grid connection. This is actually this is known as stand-alone mode of operation on the mini grid system. So we cannot call this microgrid. We can call, but the point is here the main grid is absent. So main grid is absent. So in that sense, that kind of environment in smart grid is known as mini grid. So you may ask me then how to connect this kind of network to the other network. Yes, we could have the communication wise, we can definitely connect this network to nearby network. So that is again in the process. That is again in the research process. Okay, so these red lines are basically AC lines, and the green lines are in the DC lines. Okay, what is again nanogrid? So once I said to you that you may be confusing, so don't confuse. Like initially, I said to all of you this: what is smart grid? Why we are so much interested for smart grid? What are the limitations associated with the conventional grid? And then I talk about what is our challenges and how it can fulfill by this smart grid and its characteristics and definitions. Then what is the microgrid and this mini grid, and then we'll talk about the nanogrid. Okay, nanogrid is again the smallest portion of the microgrid and then smart grid. So this nano is word itself is very small. Okay, so and it is understood by IEEE standards also. It is found, and this size, this nanogrid, maybe in the range of less than 50 kilowatt. So in that sense, one simple building can just act like a nanogrid. Okay, and its power handling capability may be less than 50 kilowatt. So that is what is one building can act like a nanogrid. So like residential, small commercial site. So this picture will help us. I think many of your doubts can be cleared from this picture. It's the bold blue patches, square figures. It is known as like we have. Let me tell you first the sky one. The sky one is a nanogrid, small rectangular pieces, and inside there are so many nanogrids inside one microgrid. This is my microgrid, the blue one, and then if we combine so many microgrids, then I'll reach to my smart grid. Isn't it? It's very quite interesting. First, I have nanogrid, small, areas, buildings, and then they are interconnected with each other to make one microgrid. And again, so many microgrid areas are interconnected with each other to connect the major grid or smart grid. Okay, so this is how the things we should understand in an easier manner. Okay. So this is how the definition of S, again you can think like nanogrid is this again the smallest cornerstone of the microgrid, and again the microgrid is the smallest cornerstone of the smart grid, like this. So we have to move like in a ladder kind of thing. So this nanogrid is a power distribution system for a single house or small building with the ability to connect or disconnect from power entities via a gateway. Okay, so here I have shown some controller, like what are the components inside a nanogrid. In fact, if somebody, I'm just trying to from myself also, I am also part of that. So we all are part of that. If we can realize a small nanogrid within our campus itself, within our building itself, within my office laboratory itself, so I hope we can think of to implement in reality a practical field the microgrid and then smart grid. It is not a very big task if you can do some smaller things initially, and then of course the other enhanced version can be done. But if we do not know understand a smaller thing even, so we cannot understand the bigger thing. So similarly, here in this nanogrid, we have renewable sources, as I said. Suppose in our villages and our areas, I have seen that people are just putting some rooftop mounted solar plants, solar panels to just catch the power from there, and they can utilize for lighting purpose or storage or some pumping the water or some kind of fan or some loads they can run from there. It's a very good practice. Okay, even in Roorkee IIT also, we have around 8 megawatt of power capacity, handling capacity of our network, and we are getting around 1.8 to 2 megawatt from the solar, rooftop mounted solar. So this is a good practice. Renewables, the major part of the nanogrid, microgrid or smart grid. Then storage. Of course, see, if we do not have storage, then you forget the smart grid concept. You forget the definition of smart grid. Storage is must. Okay. Then we have nodes. We have nanogrid controllers, central controller, and the central controller will access the data from all the renewable sources. Non-renewable source means what? Here it is renewable source. Non-renewable means that is the main grid. The main grid we are thinking that is a coal-based generation. Okay, so we should utilize. We should try to utilize more and more energy from the renewable side, less and less energy from the your substation side or non-renewable side. So we have nodes, gateway. For the gateway, we can talk to other agencies, power entity, or external world. So this is how the things we have in a better picture I have kept. We have solar energy storage. We have, this is actually our main grid, as I said. In the nano grid, in the mini grid, there is no connection of the main grid, but here in the nanogrid we have the connectivity to this area of nanogrid, and here we have the renewable sources. Let us say this is PV. The output of the PV is DC, and this PV inverter converts your DC to AC, and this is my AC bus. And we have energy storage, and this energy storage has a bidirectional converter, which can basically take the power AC to DC, DC to AC. And then we have a smart meter which will connect or disconnect this grid. When there is some disturbance on the grid side, then this smart meter will sense, it can detect a disturbance, it can connect this nanogrid to the main grid, or also it can disconnect this nanogrid from the main grid. So, and then we have other side, we have loads, And we have converters. This is actually an AC bus, and from this, if we have some DC loads, then we can convert AC to DC, and therefore it is written as converters. And overall, we have this solid lines. Blue solid line represents the power exchange, and this red dotted line represents the communication infrastructure. So finally, we have a nanogrid controller, and this dotted lines you can see here, this red dotted lines which connect to the main grid, smart meter, and this all the inverters, converters. Why? Because let me tell you, you can also think about it. Why these dotted lines are connected to these converters, inverters? Because these converter inverters are active in nature. By active, all the power to mix equipments like IGBT, GTOs, diodes are present within these converters. So this controller has to control to what? To the passive elements or active elements? To the active elements. These are the active elements. Okay. So from this nanogrid controller, it can control the duty cycle of those active elements, and accordingly, our operational behavior of the nanogrid also will change. So finally, this is a good picture, and I hope all of you will understand it nicely. That this is one nanogrid, one building. This is one more nanogrid. This is more nanogrid, and then when all together they are combined, so they are just constructing one microgrid. And then from the microgrid, it is connected to the grid. Very beautifully, it is actually designed this picture. Okay, so in that sense, I hope all of you understand from the starting point that when I started, what is smart grid? So, and what is the necessity of smart grid, and what are the shortcomings associated with this conventional grid? So that we are mad for this smart grid concept. In fact, all over the world, everybody has some curiosity, some research, some industry funding, some research funding. So everywhere is a kind of like some kind of alarming situation, some trend you can say. So everybody is aspiring towards this. Why? Because our next generation, who knows, they are just going to be completely dependent on the smart grid concept. Like renewables are there at the doorstep. Availability will be there, storage will be there, electric vehicles will be there. So therefore, we have to make some footmark, like roadmap for that. How much we can do, what we can do. So this smart grid, microgrid, mini grid, nano grid. So we have to understand slowly, one by one. And what are its features, what are shortcomings, requirements, challenges. Those points also we have to digest. We have to understand. So, of course, because when we are going to handle some problems, we have to digest the problem properly. We are not digested the problem properly, then we cannot give any solution for that. So, like we are going for a doctor, so doctor will understand, diagnose the patient first disease, then he will prescribe some medicine. Similarly, we are in the process of collecting all the difficult situations, all the information, and doing hard research, hardcore effort that in industry built, in the academic front, at the other research R&D sectors. So what could be our possible roadmap? Quickly, we can have this facility within the energy network. So as the market segments of microgrid is concerned, we have different types of microgrid. You can see actually depending on the utilization type, the microgrids are just I have shown in the picture. But if you see the supply concept, we have AC microgrid, we have DC microgrid, we have also hybrid AC-DC microgrid. Okay, so hybrid means we have both AC side and also DC side. So we can supply AC loads and also we can supply DC loads. But from the utilities point of view, like we have campus institutional microgrid, like IIT Roorkee is behaving just like one campus microgrid. And very honestly, I'm speaking, military base, they are just taking the largest advantage from this microgrid concept. They are just exploiting the solar, wind, diesel, biomass, some kind of backup batteries for their emergency operation. So remote off-grid, microgrid, community microgrid, then commercial, industrial microgrid. Now, in many industry, they are just trying to have their own captive power plant where they can generate their own generation to some extent from the renewable side storage. So those are, in that sense, if you see market growth in military is the highest and other side in the downstage. Okay, so I think I should stop here. Any questions from your side? Please tell me so that I can take questions. Let me stop here as I hope that I want to discuss more, I mean, any conceptual things we can do so that I can share with all of you.
Okay.
Okay, yeah.
So from the participant, if anyone want to interact with ma'am, please.
So maybe they can, I mean, suggest something regarding this field,
Yes.
or they can share their journey or their what kind of initiation they are taking in this area. I can definitely, I want to be part of it, so that this interaction will be much more interesting. And I know that time is a constraint, so there are so many other aspects of this smart grid era. So you listen to many other eminent speakers, but I have just started with some introduction to this particular course, with the definition of smart grid and the shortcomings associated with the conventional grid and microgrid, mini grid, and nanogrid concept. So please, you can carry, you can ask questions or some of your suggestions as well. Yeah. Or maybe next 15 minutes also I can continue if you don't have any interactive points. Yeah.
It is requested to participant if you can write a question in chat box also,
Yeah,
and
yeah.
I will.
If you're interested, you can also write in the chat box. You are most welcome. You can also write in the chat box. That will be much, much better for me. I can read and I can also answer you. Okay? Yes.
Ma'am, I think we should continue. If anyone have will questions,
Yeah.
surely they will write in chat
Okay.
box.
Okay. Fine. So now I'll just tell you a very interesting fact of these issues. I'll come back. What are the issues associated with this? After this, we'll stop. Very important issue I have taken off for all of you. That see, as I said from the beginning, we have like what is smart grid, what is microgrid, mini grid. It's fine, but the point is now, what are the challenges? What are why our vision should be strong? Because if you, as I said from the beginning, the smart grid is not a product, it's not a service. Rather, it's a kind of vision. We have to very strong in our vision. So in that front, if you are going to access some facility, so we have to take the advantages, we have to take some benefits. So at the same time, we have to also definitely be ready to accept the challenges. Okay, so the challenges are always there. So in smart grid, you cannot say this less challenges are just very easier. No, not at all. So there are so many challenges are lying in front of us, and we have to like stand and we have to accept those challenges, and we have to give solution to those challenges. So let me tell you, there are so many. I'm just talking to his challenges means the issues. Okay, so there are so many issues are existing. So like first point is you have like stability issues. We have how to design. Like there is a virtual inertia concept which is coming up. So virtual inertia means nowadays this national grids or microgrids or smart grid, they are actually populated with the converter-based renewable sources. So when the converters are in the present in the network, so their inertia concept, inertia of the network reduces. So that case, how to overcome that concept as well. And third point, how to have a very good, dedicated and well-designed technology for the storage system. Okay, just like your lithium ion battery, ultra capacitors or super capacitors or lead acid batteries. So, and again, how to improve different type of design, a very good topology, like ADC, DSC converters, or we have inverter converters from renewable sources. And of course, not only that, how to design a very good controller for that topology and filters as well. So there are so many challenges, and one more prominent aspect is the protection challenge. So protection challenge and monitoring aspect also. So in our group at Roorkee, we are working towards this monitoring, protection, control, and power quality issues of the smart grid environment. Okay, so there are so many protection issues, and one just see, I said volt bar issues and like voltage issues, frequency deviation issues. So how to correct it? How to? But if you are just going to integrate storage, we have to integrate the renewables, we have to integrate the information technology, communication technology, everything will integrate, no doubt. But you don't think that there will be some problem? Yes, there will be some problem. So we have to solve it. And then if we can solve it, then of course our operation will be successful. Otherwise, our operation is not successful. So somebody may tell that, okay, the existing grid has its protection philosophy, so I'll just integrate the renewables as much I like, the loads as much I like. That is not possible. We have to design properly, we have to plan properly, and we have to reconfigure as the requirement according to our requirement, and then we have to develop a very adaptive dynamic philosophy of the protection scheme for the smart grid, where we have renewables, we have storage, we have loads, and which we are calling it as a smart grid. Okay, so conventional grid cannot accommodate this philosophy or this interconnection of the renewables and storage, or some pushing the more power to the load centers. So we have to do some alternative. We have to think some new technology. So out of it, islanding detection is one of it. Just I want to, because it's a quite interesting topic. So it may be maybe some many participants there from other backgrounds like electronics, electrical, computer science, maybe some other. In fact, mostly I hope they're electrical. But still, their research areas may be different, their motivations are different. But this islanding is one of such topic which can merge with everyone. Somebody's interested in power tools, control, some power system or instrumentation. So every field it fits. So this islanding means the microgrid when it is disconnected from the main grid. Okay, why? Because due to some disturbance on the main grid side, the main grid breaker, this one is opened. So rest of this microgrid system is disconnected from the main grid, and that is known as islanding scenario. So islanding may be of two types. Okay, so one is unintentional and other one is the intentional. So unintentional is what? Suppose the operator doesn't know, the operator is not aware about it, that the microgrid is disconnected from the main grid. Some disturbance is there in the main grid side, and the microgrid is disconnected. So in that case, what happens? Unintentionally, the microgrid is disconnected from the main grid. So what will happen? See, for example, that kind of islanding scenario is called as unintentional islanding. But if suppose the main grid has some problem and the breaker is opened, but intentionally I just intentionally islanded some portion of my microgrid or my electric network, then it's fine. That is known as intentional islanding. So what is the problem? What's the problem with this? The problem is that when this is disconnected from the main grid, my generation and the load demand mismatches. Let us say these loads are 100% and these renewable sources are supplying, let us say 20% or 30%, and the main grid is supplying rest of the power, like maybe 60% and 70%. Okay, 80% and 70%. So now the main grid is off. So then we have only 20% availability of power from the renewables. Then we have 100% load. That means there is a power mismatch, active power mismatch and reactive power mismatch between the generation and the loads inside the microgrid. So this leads a violation in the voltage as well as the frequency. So what will happen in this process? The power point will be affected, resynchronization process will be affected, some loads will be affected, then some crew person will be affected, and it is also seen that if this main grid is disconnected, some controller of this renewable source inverters, they are going to change their control strategy from one control strategy to other control strategy. So in that sense, we have to also look after the control strategy or behavior of the inverters of the renewable sources. But so many issues may arise one by one. So therefore, it is recommended by IEEE standard that we have to de-energize these renewable sources within 2 seconds. And this process of de-energization is not so easy. So therefore, we should have very dedicated islanding detection scheme. In fact, nowadays the industry people like ABB, they are doing one very fantastic work, that they are embedding this technology, islanding detection technology, inside the inverter of the solar system or wind system or battery or whatever the renewable sources, inverter interface renewable sources are there, so that we can easily, the inverter itself, we can say, and that there is a islanding problem, means the microgrid is disconnected from the main grid, so that it can de-energize the electronic devices and the renewable sources will stop supplying to the main grid, the microgrid or loads, so that we can save our loads and the power quality issues. So this intentional islanding is what I have just given one blackout situation, and in one of my slides, that when there was a blackout in IIT in northern side, Delhi NCR. So that time intentionally the metro area was disconnected from the main network, so that metro area can run easily with some backup supply, maybe some brilliant generator, some battery, whatever. And similarly, the airport side also it was disconnected. So that is known as intentionally we have tightened it. Okay. So these are some of the tasks which is also going on the starting point of the protection philosophy. And maybe if I get some chance, you can also participate. So today I'll stop myself here. And so in future, if in Roorkee also we are going to, yeah, so I can show you some laboratories we have developed. So this is some of the real-time smart grid laboratories we have developed at Roorkee, that we have just whatever the microgrid I said, we are developing inside a real-time digital simulator RTDS. And from here, we are taking the signal here. So GTO card, this card is shown here. You can see here GTAI, GTO card, and we're taking to a DSpace real-time digital simulator. Here our technique will run, and again some decision will come back to the RTDS. And this RTDS is a real-time platform, means whatever the simulation we are doing here, it is just same the wall clock timestamp. Because in MATLAB we are doing something which may not match my real-time timestamp. Okay, so in that sense, and this platform will give you the real actual time, how much my technique is executing, it's taking for execution of it, so that I can apply some patent and I can transfer this knowledge to the industry, and so that industry can implement in real field. Okay, so this is one of the agile test bed we have in Roorkee. One more laboratory also we have, Premlata versus partner lab we have at Roorkee. This lab has, here you can see, this is the solar emulator. This one is solar emulator, and this is the wind emulator we have. Okay, this is a wind emulator. We have here this is actually a fuel cell base hydrogen. It comes here, it will be converted here to energy. And the back side we have batteries. Here I think have some. This is the battery bank, inverters, transformers. Okay. So anytime we organize any workshop, so where I am delivering these lectures, I can also invite you people. You can also join and take more things, knowledge. Okay, so I remain here. Thank you so much. If any questions, then you can stop.
Uh, Thank you, ma'am, for this wonderful lecture. One question from one participant, PK Verma. He's asking what is the impact of cyber attack in smart grid?
Yeah, that's very good. Nice question. See, actually, cyber attacks, cyber and physical. This is, we call it as a new project from DST. We launched, and in fact, many of us we are participating, and research is also going on. Cyber means we have like codings, soft platform, and physical means hard platform. The hard platform means we have solar, wind, renewable sources, and the soft platform, as I said, we have communication infrastructure, IT infrastructure, sensors, and their controllers. So the impact of cyber attacks in smart grid is going to be reduced a lot. Earlier, the cyber attack was also there in the conventional grid. Cyber attack means somebody has to like puncture your can mute unmute the things and can operate open and close the breakers. They can the attackers, they can do any kind of attacks. But cyber attack is also again very furious, very dangerous in a situation like in smart grid. But the point is we are making the codes, we are making such technology in smart grid that the attack will be less, and that is actually the very private coding system, which because that's a completely different topic. But I can assure you that we are making such like nowadays you can see smartphones. In the smartphone, nobody can just hack your phone or hack your account. So similarly, we have to maintain a very strong cyber philosophy or cyber technology for smart grid, so that the attacker cannot attack our main server or main communication platform. So then only we can just make it cyber free attacks. So we are mostly utilizing the artificial intelligence technology for it. There a lot of research is going on that. Is it okay, PK Verma? If I'm right?
Yes, ma'am.
Thank you.
Thank you so much, ma'am.
I just tried to my best to explain that. So you can read more on that. One faculty from US, one of the group people that are working on that from the Washington University. So Srivastav, Professor Srivastav, we can see their things. Okay, so what are the different types of protocol used in smart grid? See, actually there is a IEEE standard. You can write the standard name. If you time your college permits IEEE connection, then you can download, or I can also sometimes you can connect me. I can send some, write my email ID. I can send some standards to you, like some kind of IEEE standard IEEE 1547 series, 1547.123. So many standards are outlined. So every smart grid philosopher, utilizer, or customers, they have to follow those standards. Otherwise, it is not possible. Those protocols, like communication protocols, we have power protocols, we have architectures, it's standards, so voltage limitation, frequency limitations, everything. And all the points are written in that IEEE standard that is known as 1547 series. IEEE 1547.1.2 up to I think point 10. You can download. Okay. And one more question. Ma'am, what is the scope of power generation through piezoelectric materials? Yes, that is fine. See, actually, we are just trying to see to develop the piezoelectric material. We need some industry, and that industry also needs some power supply. So if we go for wind and solar, and where I'm not saying that for solar material construction, wind construction, also we need some industry. But there the chances of like abundantly availability of the resources are there, so that we can just take the energy with less effort, we can get more power. So that should be our target. See, our target is what we are not going to violate the environmental issues. We are not going to violate the environmental issues. We are not going to generate more carbon dioxide emission to the environment. At the same time, we are utilizing the completely available energy like solar energy, wind energy, then we have to okay, madam, any power grid challenges in this topic area? Yes, yes. There are so many power grid issues. Like the first issue is the harmonic injection because in smart grid we are using lot many converters. Like with solar, the main equipment is DC-DC converter and the inverter, like which converts DC to AC. And similarly, in many other cases also, like wind also, we use the converters. So there is a very good chance of generation of like harmonics, and also the frequency voltage variation is quite convenient. So therefore, like voltage unbalancing means when we integrate the electric vehicles to the existing grid, single phase charger, three phase charger, so this voltage unbalancing takes place. Suppose you are supplying three phase solar to a particular load, so one phase solar panel has some problem. Even the generation may be also unbalanced. So therefore, there is a very good chance of fault issues in this smart grid environment. So many research is also going in this direction. Okay. Okay. So one question:
One
how
more,
can
yes,
I
one
design?
more question is from Kapil Gandhi. He's asking, how can I design hybrid microgrid test bed on MATLAB?
Yeah, so in MATLAB actually we have already inbuilt systems. I hope you can go to the demo section, demo files, and the demo files. There's a 9 bus AC grid system, and you can take that and you can connect some kind of bidirectional converter, and that side you have AC, this side AC, and so the bidirectional converter you have to connect the to AC grid and DC grid. That will act as a hybrid microgrid test bed like this. Is it okay?
And one last question is asked by
So
ma'am,
see,
which software
actually,
is
yes, any software like MATLAB, as I said, it is the best one. But in our laboratory, we are using RSCAD software, PSCAD also sometimes. The PSCAD is also far better than MATLAB because MATLAB has no EMTD property. EMTD means electromagnetic transient containing DC. So, and that in that sense, you can use MATLAB, but for my advice, you can go for ETAP is one good solution software. PSCAD is one another more software because in many worldwide they are not focusing on the MATLAB anymore because MATLAB is a platform. I'm not denying, but where you have electromagnetic transients, the non-linearities which are associated with the actual network, that cannot reflect in MATLAB as well. So therefore, we have take some software where it can also kind of like ETAP, maybe PSS of Siemens group of companies. Then you may take PS card. RS card, as I said, that is a part of RDS. So those softwares I can suggest. So I hope, yeah. So some question, so the software for hybrid wind and solar. Yeah, this one you can take from MATLAB itself. If you do not have any facility from PSCAD, PSCAD, I think 2-3 users, 2 users if I'm not wrong, around 4 lakhs. There's a NIAC group of company, NIAC power system company, so you can purchase from there. Maybe for the institutional discount is there, you can take from there. So then you can take help like from us also, like IITs. The see in many IITs are also property of the whole nation. So we have so many software platform, we have hardware platform. So I hope that in fact IIS Bangalore has taken some steps to the Government of India initiation that they are making a central equipment list, software and hardware list, so that every country people, researchers, students, teachers, industry people, they should be also benefited through this portal. So that is coming up very soon, and anytime you are also most welcome. Have a small visit to IIT Roorkee. IIT Roorkee has many facilities as a smart grid is concerned. So, so I think today is this much. So
Thank you,
next
ma'am.
week, yeah. So we'll meet
Thank you,
again.
ma'am.
with some, if I'll conduct any workshop or something night, okay. So I'm delivering there the lectures. First preference will be you people. So I'll invite
Thank
you
you.
people. Okay. Some
Thank you, ma'am.
hands, yeah, hands-on training or some discussion. So keep your track. Yeah. Thank you so
Okay,
much.
thank you, ma'am. Thank you, ma'am, for this wonderful lecture. And
Hmm.
hope our participants also enjoyed and learned a lot of things and may start their career, their research, and got some information also. So
Yes.
thank you, ma'am. Thank you very
Thank
much.
you so much. So I'll quit now. And
Yes, ma'am.
thanks
Yes, ma'am.
to your coordinator, Rajkumar sir, then Singh sir. He used to call me every time. So, anyways, thanks to your coordinator and authority for inviting me again.
Thank you.
Thank you so much. Have a nice day.
So, participants, the next lecture will be at 2:30 p.m. and the lecture by Professor R.K. Vara from IIT Patna. So, we request you all to again join us at 2:15, and we will start our session at 2:30 p.m. Okay, thank you. Attendance already given in the WhatsApp group, so you can get attendance link from there and you can mark your attendance.